Hello students, welcome. In this video we are going to study the chemical kinetics part 3. In part 2 we discussed factors affecting rate of reaction and how to write rate law expressions, rate constant, etc. In this video our first topic is distinction between rate of reaction and rate constant. Both topic is already discussed in the previous video. So here we are just differentiating the rate of reaction and reaction rate constant. So the first one is rate of reaction is the change in the concentration of reactant or product per unit time, and reaction rate constant is a constant of proportionality in the rate law equation and is equal to the rate of reaction when the molar concentration of the reactant is unity. That means अगर हम सभी reactant का molar concentration unity, that means 1 molar concentration अगर लें at a particular temperature, then its rate will be constant. उसी को हम क्या कहेंगे? Reaction rate constant. But actually what is the rate of reaction? So rate of reaction is simply the change in concentration per unit time. This change in concentration may be of reactant or may be of product. The second difference is the rate of reaction at any instant of time depends upon the molar concentration of the reactants at that time. That means if the molar concentration is high, then the rate of reaction will also be high. If the molar concentration of reactant is low, then rate of reaction will also be low. But the rate constant for a particular reaction is depend only on temperature and does not depend on the concentration of reactant, because we are taking concentration of reactant as 1 molar. Its unit is always mole per liter per time, but unit of rate constant depends on the order of the reaction. So order of the reaction will be one of the most important topic in this video. But before starting order of reaction, we must discuss about molecularity of reaction. So what is the molecularity of reaction? The molecularity of an elementary reaction is the number of reactant molecule taking part in the reaction. Molecularity of a reaction is a theoretical value and is always a whole number. For example, here we consider example ozone and oxygen, both are combining together and form oxygen molecule. Right, so here 1 molecule of ozone is involving and 1 atom of oxygen is involving, so it's a bimolecular gaseous reaction. Similarly, 2NO plus H2 gives N2 plus H2O2. Hydrogen peroxide and nitrogen are the product. Here 2 plus 1, total 3 molecules are involving. That's why this is a trimolecular reaction. We can take many more other examples. So in very simple words, जब हम लोग एक सामान्य एक जनरल केमिकल इक्वेशन लिखते हैं, सो वी ऑलवेज यूज़ अ बैलेंस्ड इक्वेशन. हम उसको क्या करते हैं? बैलेंस करते हैं. तो जो भी नंबर ऑफ मॉलिक्यूल्स आर इन्वॉल्विंग for in a balanced chemical equation, उसका sum total करना है, and that will be the molecularity of reaction. So in case of molecularity, we can just calculate or predict the molecularity of reaction by looking forward a balanced reaction. आपको क्या करना है? सिर्फ एक balanced equation लेना है, and only on calculating number of molecule of reactant or number of mole of reactant हम क्या कर सकते हैं? molecularity find out कर सकते हैं. But there is another aspect that is called order of reaction, which is related with mechanism of reaction. So before starting order of reaction, we must know what is the mechanism of reaction. So a reaction mechanism is the sequence of elementary step by which a chemical reaction occur. Here a new word that is called elementary reaction. What is the elementary reaction? किसको बोलेंगे हम elementary reaction? So the reactions taking place in one step are called elementary reaction. Listen once again. The reactions taking place in one step are called elementary reaction. ऐसे सभी reaction जो सिर्फ एक step में complete हो जाते हैं, they are known as elementary reaction. Okay, so a reaction mechanism, कोई भी reaction का mechanism is a sequence of elementary steps. That means there are more than one steps are involved in a common chemical reaction. So a reaction that occur in two or more elementary step are called multi-step or complex reaction. तो generally जितने भी reaction होते हैं either उनमें टू और मोर देन टू एलिमेंट्री स्टेप्स ज़रूर होते हैं. सो अ रिएक्शन इंटरमीडिएट इज़ अ chemical species that is formed in one elementary step and consumed in subsequent step. So there is a formation of a reaction intermediate which form in one of the elementary step, and that will be immediately consumed in a other एलिमेंट्री स्टेप. जो इसके नेक्स्ट बाद वाला जो सब्सिक्वेंट स्टेप होगा उसमें वो कंज्यूम हो जाएगा. दैट मीन्स द रिएक्शन इंटरमीडिएट बहुत ही शॉर्ट टाइम ड्यूरेशन के लिए फॉर्म होता है एंड इमीडिएटली इट कंज्यूम्स इन अदर स्टेप. So the slowest step in a reaction mechanism is known as the rate determining step. So it is a very important question, what is the rate determining step. तो वहाँ पर आपको बताना है the slowest step in the reaction mechanism is known as the rate determining step. The rate determining step limits the overall rate and therefore determines the rate law of the overall reaction. Now this is a very important topic, very important point कि ये जो रेट डिटर्मिनिंग स्टेप है एक्चुअली इट लिमिट्स द ओवरऑल रिएक्शन एंड दैट इज गोइंग टू डिसाइड द रेट ऑफ रिएक्शन. सपोज देयर इज अ साइकिल फैक्ट्री एंड देयर आर वेरियस यूनिट्स फॉर द प्रिपरेशन ऑफ पार्ट्स ऑफ द साइकिल. सो number of cycle, how many number of cycle are producing at once will be decided by the slowest unit. इसको आप ऐसे समझिए, मान लीजिए एक साइकिल की फैक्ट्री है, उसके पार्ट्स के फॉर्मेशन के लिए अलग अलग यूनिट बने हुए हैं. तो पर डे हाउ मेनी साइकिल्स आर गोइंग टू प्रोड्यूस, उसके लिए कौन रेस्पॉन्सिबल होगा. सपोज अगर हैंडल वाला यूनिट है वो पूरे ओवरऑल डेज में सिर्फ 5 हैंडल बना रहा है, बाकी जो है वो बहुत सारे पार्ट्स प्रोड्यूस कर रहे हैं बट हैंडल इज ओनली 5. सो द टोटल नंबर ऑफ साइकिल विल बी प्रोड्यूस इन वन डे विल बी इक्वल टू 5 एंड दैट इज गोइंग टू डिसाइड by the number of handle. Similarly, what happens in case of chemical reactions, there are many steps, there are many elementary steps, and out of them the step which is the slowest will going to decide the overall rate of reaction. फॉर एग्जाम्पली यहाँ पर कुछ एग्जाम्पल्स मैंने कंसिडर किए हैं. थर्मल डिकम्पोजिशन ऑफ डाइनाइट्राइट पेंटॉक्साइड. हियर 2N2O5 इज डिसोशिएटिंग or decomposing in 4NO2 plus oxygen, right? So according to the rate law, rate of reaction will be K concentration, molar concentration of N2O5. Okay, this according to the rate law, it's not here exponent में हम यहाँ पे 2 नहीं लिख रहे हैं, पावर में 2 नहीं लिख रहे हैं, because it involves 2 step. In first step, nitrogen pentoxide is going to decompose into NO2 and NO3. In the second step, the second molecule of N2O5 is combining with NO3 and forming 3NO2 plus oxygen. So the second step is fast and the first step is slow. So step 1 is the rate determining step. That's why it's going to decide the overall rate of reaction. That's why it's order of reaction will be 1. Here it's a bimolecular reaction. Why? Because in a balance equation there is a involvement of 2 molecule. ये देखिए यहाँ पर जो आपने एक balanced equation लिखा उसमें 2 molecule of N2O5 involve हो रहे हैं. That's why its molecularity will be of 2, right? But in elementary reaction rate determining step में there are only 1 molecule is involving. That's why it will be a reaction of first order. देखो both the above step are elementary reaction. The slow step is unimolecular whereas the fast step is bimolecular. ये जो fast step है here 2 molecules are involving, but this in slowest step only 1 molecule is involving. Hence the above reaction is unimolecular reaction or a reaction of first order. Okay. There is a second example. Here also its molecularity is 3 because 2 plus 1 will be equal to 3. Now it also going to complete in 2 step. This one is the slow step, step 1. The step 2 is the fast step. So the slow step is bimolecular, that's why the reaction will be of second order reaction. अब आप लोगों को ये शायद मन में क्वेश्चन आ रहा होगा कि हाउ विल यू डिसाइड कि हाउ मैनी स्टेप्स दीज रिएक्शंस आर गोइंग टू टेक प्लेस. तो ये जो है आपको एक बैलेंस्ड इक्वेशन देख के नहीं पता चलता, इट्स एक्सपेरिमेंटल वैल्यूज़. तो ये आपको बिकॉज इन द होल केमिस्ट्री बुक देयर आर लॉट्स ऑफ रिएक्शन, सो आप तो एक्सपेरिमेंट करने जा नहीं रहे हो, तो आपको कुछ जो रिएक्शंस बार बार रिपीट होते हैं वो आपको याद करने पड़ेंगे कि हाउ मैनी स्टेप्स दे आर गोइंग टू कंप्लीट. द थर्ड एग्जाम्पल इज हियर NO2 plus carbon monoxide are combining together and forming CO2 and NO. So experimentally the rate expression is NO2 means concentration of nitrogen dioxide. So here this is the slowest step, step 1, and this is the fast step. So here the slow step is involving 2 molecules, that's why it is also a reaction of second order. So here molecularity is also 2 and order of reaction is also 2. So here both molecularity and order are same. So what is the difference between molecularity and order of reaction? First of all, molecularity is the total number of molecules which participate in a single step reaction. It is number of molecules whose concentration is changed and may change the rate. That means what happens in case of order of reaction? If we are changing the concentration of molecule, then the rate of reaction will also alters. But molecularity is the simple number of molecule which is involving in a single step reaction. The second one is it is a theoretical constant, means molecularity can be calculated by looking forward the balanced equation, but order of reaction is calculated only experimentally. It is the whole number, it is always a whole number, but order of reaction may be 0, may be in fractions, may be whole number. Molecularity, in case of molecularity, 0 value is not possible, but 0 value is possible for order of reaction. It does not provide any information about mechanism of the reaction, but order of reaction provides information about the mechanism of the reaction. It is related to a specific step of reaction. It is related to the overall reactions. Molecularity of the reaction is not related to the concentration of reactants and rate. It's just an information about the total number of molecule. But in case of order of reaction, it shows a relation in concentration of reactants and rate. सो इंटीग्रेटेड रेट इक्वेशन, हम किस तरीके से इंटीग्रेटेड रेट इक्वेशन लिखते हैं? सपोज दिस इज अ जनरल रिएक्शन वेयर स्मॉल a molecules of reactant A and small b molecules of reactant B are combining together and forming C molecules of product C and D molecules of product D. So simply we can write the rate minus D molar concentration of R divided by dt. Here R for reactant, and यहाँ पे हम माइनस क्यों लिख रहे हैं? बिकॉज रिएक्टेंट का कॉन्सेंट्रेशन कंटिन्यू डिक्रीज होता जाता है. सो विल बी इक्वल टू के ए टू द पावर अल्फा and here b to the power beta. That means the whole A molecules are not involving or the whole B molecules are not involving. Only the alpha part of A and beta part of B is going to involve. So this is the equation for rate, and this form of the equation is called differential rate equation. ये जो हम d upon dt के फॉर्म में लिखते हैं, इसे हम क्या बोलते हैं? differential rate equation. But this form is not convenient to determine the rate law and hence the order of reaction. Why? Because the instantaneous rate has to be determined from the slope of a tangent at the time t in the plot of concentration versus time. Means हमको क्या करना होता है? We have to draw a graph between concentration and time. फिर हम क्या करते हैं? उसका एक tangent लेते हैं and उसका स्लोप निकाल के उसके स्लोप से हम रेट लॉ और ऑर्डर ऑफ रिएक्शन कैलकुलेट करते हैं. बट इट्स नॉट वेरी कन्वीनियंट एंड मोस्टली इट लैक्स एक्यूरेसी. ठीक है, इनकन्वीनियंट भी है एंड एक्यूरेसी भी बहुत ज़्यादा नहीं होती. सो ओवरकम द अबव डिफिकल्टी वी इंटीग्रेट द डिफरेंशियल इक्वेशन फॉर द रिएक्शन ऑफ एनी ऑर्डर. तो हम क्या करते हैं, डिफरेंशियल फॉर्म यूज़ ना करके इंटीग्रेटेड फॉर्म यूज़ करते हैं. दिस गिव अस एन इक्वेशन रिलेटिंग डायरेक्टली द एक्सपेरिमेंटल डेटा. जो भी एक्सपेरिमेंटल डेटा दैट मीन्स कॉन्सेंट्रेशन, टाइम एक्सेट्रा जो भी हमको मिलता है वो डायरेक्टली रिलेट कर सकते हैं हम बाय यूजिंग इंटीग्रेटेड फॉर्म. सो द इंटीग्रेटेड रेट इक्वेशन दस ऑब्टेन्ड आर डिफरेंट फॉर अ रिएक्शन ऑफ डिफरेंट ऑर्डर. तो कैसे कैलकुलेट करेंगे, सपोज हम एक जीरो ऑर्डर रिएक्शन लेते हैं. जीरो ऑर्डर रिएक्शन वो रिएक्शन है, अ रिएक्शन दैट हैज़ अ रेट दैट इज इंडिपेंडेंट ऑफ concentration of reactants. Means all the reactions in which the rate of reaction is not dependent on their concentration is known as zero order reaction. Zero order means zero. The word zero here reflects that the rate of reaction is totally independent of the rate of reactant. Generally हम factors affecting में क्या बोलते हैं कि concentration adversely affect the rate of reaction, but here in case of zero order reaction the concentration is not going to affect the rate of reaction. So it is a special type of reaction. For example, hydrogen and chlorine are combining together and forming hydrogen chloride. So the reaction is independent of concentration of hydrogen and chlorine. So here in the power we are using 0, right? So the total value will be of 0 and the rate will be equal to k. Rate of reaction will be equal to k for constant. So whether we are taking any concentration of hydrogen and chlorine, but the rate of reaction will be as it is, there is no change. That's why it is zero order reaction. Similarly, this is another example, decomposition of nitrous oxide into nitrogen and oxygen. This is also an example of zero order reaction. Similarly, in case of decomposition of ammonia in the presence of molybdenum or tungsten is also a zero order reaction. These all three reactions, and there are many more reactions which follow the zero order reaction. So integrated rate equation for zero order reaction, how can we calculate? Suppose A is a reactant and forming a product. So what will be the rate? Differential form इसका क्या होगा, minus dA upon dt, right, which is equal to, because this is a zero order reaction, this will be equal to k A0. A0 means initial concentration. A0 means it is following the zero order reaction, so in power we have to write 0. Okay, so minus d upon dt will be equal to k, because this value is going to be 1. ये वाली वैल्यू जो है वो क्या हो जाएगी, 1 हो जाएगी. So minus d molar concentration of A upon dt will be equal to k. Okay, now you have to rearrange the equation. So it will be dA is equal to minus k dt. ये dt को हम क्या करेंगे, यहाँ लेके जाएंगे, शिफ्ट कर देंगे to the right side, and this is equation 1. Now on integrating both side we will get up this equation number 1 we have to integrate. ओके, सो जब आप इसको इंटीग्रेट करते हैं तो ये डी वाला साइन जो है वो हट जाएगा, एंड इट विल बी मोलार कंसंट्रेशन ऑफ ए इज इक्वल टू माइनस के टी प्लस आई. हियर आई इज द कांस्टेंट ऑफ इंटीग्रेशन. नाउ वी हैव टू कैलकुलेट द वैल्यू ऑफ आई. सो एट टाइम टी, दैट मीन्स व्हेन टाइम इज 0, द मोलार कंसंट्रेशन ऑफ रिएक्टेंट विल बी equal to its initial concentration A0. A0 means initial concentration. So when we put these values in equation number 2, we have to put these values in equation number 2. So this value minus kt will be equal to 0. Why? Because t is 0. ये value क्या हो जाएगी, 0, and I will be equal to A0 like this. ओके, सो वी हैव टू सब्सटीट्यूट दिस वैल्यू ऑन इक्वेशन 2. आई की जगह पे हमको क्या रखना पड़ेगा, A0. सो वी विल गेट द इक्वेशन नंबर 3. नाउ वी हैव टू रीअरेंज द इक्वेशन नंबर 3. इट विल बी इक्वल टू KT इज इक्वल टू A0 माइनस A. ओके, जब ये आप नीचे में 0 लगा रहे हैं इट इंडिकेट्स द इनिशियल कॉन्सेंट्रेशन, और जब आप यहाँ पावर में 0 लगाते हैं तो वो उसके रेट लॉ को एक्सप्रेस करता है. सो वी हैव टू रीअरेंज टू गेट द k is here rate of equation. It will be 1 by t A0 minus concentration of A. So this expression is for rate constant or rate of reaction of zero order reaction. You have to practice this for 3 to 4 times. Definitely it will be very easy for you. This is a graph between concentration and time. Okay, so initial concentration जो है वो कंटिन्यू डिक्रीज होता जाएगा, and but rate of reaction is will be as it is. That's why there is a parallel line, because here in normal cases what happens, the rate of reaction when depends on the concentration, the rate will also be decreased with time, but here rate of reaction is independent of concentration. That's why we are getting the rate of reaction as it is with concentration and with time also. Okay, now half-life period for zero order reaction. Half-life period is a time when the concentration of a substance will be just half, means at half-life period T will be T half, and A that means the concentration at time T 1/2 will be equal to A 0/2. That means half-life period हम किसे बोलते हैं, when the initial concentration of a reactant will be just half. मतलब जितना भी concentration है उसको just half होने के लिए how much time is required, that is called its half life period. That's why T को हमने यहाँ पे क्या लिया, T half, और जो final concentration है उसे क्या लिया, just half लिया initial के. Okay, so this equation is the rate equation for zero order reaction. Here we have to put the values of time T and A. तो A की जगह पे हमको क्या रखना है, A 0/2, and T के प्लेस पे हमको क्या पुट करना है, T half. So it will be like this. ठीक, पहले तो T को हम क्या करें, शिफ्ट कर लिए. Okay, now we have to put the value here T and here for A. So it will be like this. It will be T half and it will be A 0/2. Now you have to solve this equation number 3, and you will get, because it's the initial concentration, it's the half of the initial concentration. So what will remain, A 0/2 and K. So this is the half-life period for zero order reaction. This equations also you have to practice for 3 to 4 times, and this is very very easy. What will be the unit of rate constant for zero order reaction? It will be, this is initial concentration, that means here molar concentration will be there, and K if we shift this one here, then it will be time, right? So mole per liter upon time, that is mole per liter per second. This is the unit for rate constant, and this is the graphical representation of T half and initial molar concentration. There is a numerical question. Suppose the decomposition of ammonia on platinum surface is like this. ये equation यहाँ पे दिया हुआ है, is a zero order reaction. Here the K, with the value of K is also given, 2.5 into 10 to the power minus 4 mole per liter. So what are the rates of the product of nitrogen and hydrogen? So it is the application part, why we are studying the chemical kinetics, zero order reaction, etc. So if we know the value of K, then we can calculate the rate of production of the products. How? This is a balanced chemical equation, right? We can write the rate equation like this. It will be 1/2 concentration of ammonia divided by dt will be equal to concentration of nitrogen divided by dt 1/3 concentration of hydrogen divided by dt. So zero order reaction के लिए K की वैल्यू हम K की वैल्यू इज इक्वल टू होती है रेट के, दैट मीन्स रेट ऑफ रिएक्शन इज इक्वल टू K. सो इसको मैंने सेम एज इट इज़ यहाँ पे फिर से लिखा हुआ है, एंड इट्स वैल्यू इज 2.5 इंटू 10 टू द पावर माइनस 4 मोल पर लीटर पर सेकेंड. सो दिस क्वेश्चन इज़ वेरी वेरी इजी, लेकिन अगर आप इसको नहीं जानते सॉल्व करना, देन इट विल बी वेरी डिफिकल्ट फॉर यू. सो इट्स वेरी इजी. आप डायरेक्ट यहाँ से ये जो बैलेंस्ड इक्वेशन है उससे आप ये के की वैल्यू को रिलेट करके निकाल सकते हैं वैल्यू. कैसे? रेट ऑफ प्रोडक्शन विल बी एज इट इज़ द गिवन rate constant, that means 2.5 into 10 to the power minus 4. Why? Because only one molecule of nitrogen is getting produced. whereas 3 molecules of hydrogen are getting produced. So what you have to do, you have to just multiply the value of K with 3. ओके एंड अगर इस क्वेश्चन में ये पूछता कि व्हाट विल बी द डिसअपियरेंस ऑफ अमोनिया, तो आप क्या करते, इसको मल्टीप्लाइड बाई 2 कर देते. ओके, सो दिस इज द आंसर. So what will be the next topic in our next video? In the next video we are going to deal first order reaction, integrated rate equation for the first order, half life period of first order, pseudo first order reaction, and rate of radioactive decay or disintegration. Okay, so thank you.